Hi everyone. Now we're going to be talking about standard form versus slope-intercept form. So both of these are forms of equations of lines. They're just different ways to write lines, and they both have their pros, they both have their cons. So let's just go over the formulas really fast. So we're used to the slope-intercept form. I'm going to start with that one. So your slope-intercept form, oh my gosh, spelling. Is y equals mx plus b, where your m is equal to your slope and your b is your y-intercept. Okay, and then we have our standard form. Now, standard form is a little bit more complicated. It makes it look prettier, but it's not as helpful. The standard form of a line is ax plus by equals c, where a, b, and c are all whole numbers, and a has to be positive. So I'm going to write that down. A, b, c equal whole numbers, and a is positive. Okay, so what we're going to do with the next few examples is try and convert between standard and slope-intercept form. So let's start with one in slope-intercept form. Y equals negative 5x plus 8. And what we want to do is convert that to standard form. So the way that I like to think about this is I just want to shove over the x so that the x and the y are on the same side. So if I want to move that negative 5x over to the other side, what I'm going to do is add 5x to both sides. All right. And when I add 5x to both sides, the 5x can't combine with the y because they're not like terms, but I am going to put the 5x in front, mostly because in the standard form, the x comes before the y. So I'm going to say 5x plus y equals, and then the 5x's on this side, on the right side cancel out, so I'm just left with 8. Now, this is my standard form. It's 5x plus y equals 8. Just like that. Okay, and let's just make sure that that follows the rules of standard form. So we have all whole numbers. There's no fractions or decimals in this equation, and then our a, or our front number, is positive. So it totally works. This is in standard form. Okay, let's go through another example where it might be a little bit more complicated. So this one is, y equals 2/3 x plus 10. Okay, so what I'm going to do here is, first step is to get the x and the y on the same side. So I'm going to say subtract the 2/3 x from each side. And once again, the x and y can't combine because they're not like terms, so I'm just going to put the x in front. All right, so now we have this with the x and the y on the same side, but it's not following those two rules that we have for standard form because we have fractions. We need to get all whole numbers, and then our a, or our front number, is negative and we want it to be positive. So what we're going to do is figure out how to fix both of these problems with one thing. To get rid of the fraction, the easiest way to do it is to multiply by everything, every single chunk or every single term, by the denominator. And so I can multiply all of these things by 3, because what I do to one thing, I have to do to all of them. But instead of just multiplying it by 3, what I'm going to do is multiply it by negative 3. The reason why I'm multiplying it by negative 3 is because that front number is negative. Now, if I multiply by a negative, we know that two negatives cancel each other out in math, and so the front number will end up being positive. So now, when I do negative 2/3 times negative 3, I'm going to just end up with a 2x, because the 3's cancel each other out. The denominator of the 3 and then the 3 that I multiplied by cancel each other out, and the negatives cancel each other out. So now we've got this 2x. Now, the second part, y times negative 3, gives me negative 3y. And then we've got 10 times negative 3, which gives me negative 30. And this is in standard form. So 2x minus 3y equals negative 30. Notice how the front number is positive and the other ones are negative. I don't care whether the B and the C are negative or positive. I just care that the A has to be positive. So that's your standard form. All right, now let's go through some examples where you're moving the other way, where I give it to you in slope or in standard form and you have to convert it to slope-intercept form. All right, so we've got 4x plus 2y equals 10. All right, and then what we're going to do on here, the easiest way for me to think about this one is all we want to do is solve for y. We want to get that y by itself. So when I want to get the y by itself, the first step for me is to get rid of the x or to move the x. And the way I'm going to do that is by subtracting 4x from each side. Right now the 4x is positive, so to get rid of it, we have to make it negative. So those 4x's on the left side cancel out. I'm just left with 2y on this left side. And then the 10 and the negative 4x can't combine because they're not like terms. So I'm just going to say negative 4x plus 10. Now, it wouldn't really matter if you put the 10 first or the 4x first. We just like to put the x portion first because that's the way that the slope-intercept form looks. Okay, so now we're really close, but we still want to get y by itself, and it has that 2 attached to it. So to get rid of the 2 is multiplying the y, so to get rid of it, we're going to have to divide each chunk by 2. All right. So when we divide the 2y by 2, we just end up with y, which is exactly what we wanted. And then we have negative 4x divided by 2, which gives me a negative 2x. And then 10 divided by 2 gives me 5. So this is my slope-intercept form because now my y is by itself. And the good news here on the slope-intercept form is that we don't really care what's negative or positive, as long as that y is positive. And then we don't care if there's fractions. Not that there are fractions in here, but if there were fractions, it would be totally fine. All right, let's go through one more example. 3x minus 7y equals 21. Okay, so once again, we want to get that y by itself. So the first thing I'm going to do is subtract the 3x from each side. All right, so the 3x cancels out on the left side, and I'm just left with negative 7y. And then I'm going to say negative 3x plus 21 because those two are not like terms. We can't combine them. Still want to get the y by itself, so I've got to get rid of that negative 7. The negative 7 is multiplying the y, so to get rid of it, I have to divide by negative 7. What I do to one thing, I have to do to everything else, so I'm going to divide everything by negative 7. And I end up with just y on the left side because negative 7 divided by negative 7 is 1. Then over on the right side, I've got negative 3x divided by negative 7. Well, negative divided by a negative we know is a positive, but 3 divided by 7 doesn't simplify, so we're just going to leave it as 3 over 7x. And then 21 divided by negative 7 gives me negative 3. So my slope-intercept form is y equals 3/7 x minus 3. And once again, we're totally cool with the negatives and the fractions because this is not standard form, it's slope-intercept form, and most anything goes in slope-intercept form.